Hello everyone, I'm Paul and today we're solving problem 3397, maximum number of distinct elements after operations. This is medium and the logic for the solution is pretty straightforward. So let's start. We are given an integer array nums and an integer k. So let's say this is nums, k is 2, and we are allowed to add or subtract k from any element at most once per element. So we can run the operation here, 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 and so on, only once per element. And we need to return the maximum possible number of distinct elements that we can get after running these operations. For this input, we can subtract 2 from here because k is 2 and the new value is 0. We can add 1 here because 1 is more than 2, so the new value is 4, and we can add 2 here. The new value would be 5. And by doing this, now we have 6 different elements. And this is the maximum possible number of different elements that we can get, so we just return 6. Now we need some sort of standard process to solve this. And maybe you are thinking about sorting this, so this would be a sorted array, and iterating this from left to right and storing every element in something like a set. So first we are here, our set is empty, so we add 1, next we are here, we don't have 2 in the set, so we can add 2, next we are here, and we can add up to 2 to this number, so maybe we can replace this with 3, and here we put the 3. Next we are here, we can add 1, we add 4 here. Next here we add 2, so we get 5, we add 5. But the problem is here. Remember that the result for this input is 6, but we have 5 unique elements in our set, so we should include this element. Now the thing is, everything in the range from 3 minus 2, meaning 1, to 3 plus 2, meaning 5, is already taken. We have all of these values here in our set, so at this point we have no way to include this in the set, so we need to think about something else. And the trick here is the following. Let's say we iterate this from left to right again and we start here. Instead of keeping this number as it is, we are trying to get the minimum possible number at this point. Remember k is 2, so here we could replace this with a -1, okay? And by sticking to the lower bound for every element, we can explore a wider range. And this is exactly what we need, because we need the maximum possible number of different elements. So the final approach will be the following. First, we need to sort this. This is already sorted, and we will have a variable which we will call low. And we are storing here the low bound. This is the maximum number we have seen so far at each step. First, we are here. And we are trying to replace this with the minimum possible number. And the minimum number here is given by the current number minus k. 1 minus 2 is -1, so we replace this with -1. And the maximum between minus infinity and -1 is -1, so we replace this with -1. What this means is the maximum number we've seen so far is -1, and the low bound is given by this number. We will never go back to anything that's below -1. So this is the low bound. This is the trick for this problem. Now we are here and we do the same. 2 minus k is 0. And the maximum between 0 and -1 is 0. So we can replace this with 0. We can't use -1 here because this is out of bounds. The minimum possible number from 2 is 0 because k is 2. And the maximum number we have seen so far is 0, so we replace this with 0. We will never go below 0. Now we are here and 2 minus 2 is 0, meaning we could reach number 0, but the problem is we are trying to find unique elements. Here we have another 0. So, given that the low bound is 0, we can replace this with the low bound plus 1. So we put 1 here. Now we are here and 3 minus 2 is 1. The thing is we have a 1 here. The low bound is 1. So we replace this with the low bound plus 1. Here we have a 2. Next we are here and 3 minus 2 is 1. But here we have a 1, here we have a 2. And what we are doing, in case you didn't notice, is we take the maximum between low bound plus 1, meaning 3, and the current number minus k. And the maximum between 3 and 1 is 3, so we keep 3 here. Now we are here and the maximum between 3 minus 2, 2 is for k, and low bound plus 1, 3 plus 1, this is 1 and 4, so the maximum here is 4. So we replace this with 4. Now we reach the end of the array, and given that we have 6 unique elements, we can return 6. And we can store unique elements in a set or just with an integer. And one final thing here, let's say we add 2 more elements here, so for the sort the array we have 2 more 3s here. And we are doing exactly the same. Now we are here, so we replace this with 5. Now we are here and we take the maximum between 3 minus 2 and 5 plus 1, 6. The result for this is 6. So maybe you are thinking about replacing this with a 6. The problem is that k is 2. So we can only add up to 2 to this number. So as a maximum, we can have 5. So we can't replace this with the 6. And this means we can form a unique number with this element. So in total we have 7 unique numbers for this input, so we return 7 here. So we are sticking to the minimum possible number that we can get from every element that's in bounds and unique. And with this in mind, let's go with the code. First we need to sort nums, so nums.sort. The result is 0 initially. We are using this to keep track of unique numbers. And the low bound is initially minus infinity. And sorry, this is minus. And now we can say for every number in nums, the current low bound will be the maximum between low plus 1 and x minus k. And now we can say if current is smaller or equal to the upper bound, x plus k, we add 1 to the result, and now low is current. Finally, we can return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. Here, time complexity will be big O of n log n, and this is given mostly by sorting. And space complexity big O of 1 or big O of n if you consider the space for sorting. So this is it for this problem. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.